In the present video, we're going to study applications of the Boolean panel in logical operations. For that purpose, we're going to use its SMath Studio file. I'm going to increase 25% and show you the Boolean panel right here. The Boolean panel has some symbols that you're familiar with, except that this equal sign is a little bit thicker than the regular equal sign because it's used for comparison. It's not used for obtaining results. And then you have the less than, greater than, less than or equal to, or the greater than or equal to, or not equal to. Those 1 through 6 are comparison signs or comparison symbols. Then in 7, 8, and 9, and actually miss 10 right here, you have the negation of a logical statement, the conjunction. This is equivalent to saying and in speech, or, that's disjunction, and this is called exclusive or, which is only true when both statements are true or both statements are false. Now we're going to present some examples of application of those statements. For example, if I do this one, 4 equals 4, notice that this equal is the thick Boolean equal sign right here. And so if I now click to the right and press the regular equal sign, it gives me 1. What this is saying is like the comparison of 4 equal to 1 is true. When you get a true statement, then SMath Studio assigns the value, the numerical value of 1, indicating it's a logical value of true. If the statement is assigned a numerical value of 0, then you have a logical value of false. For example, 4 equal to 3, no. If you say equal, it gives you 0. But remember to distinguish between the thick equal sign here, that's the Boolean equal sign used for comparisons. I made a mistake here, the Control Z. I have a number of statements, logical statements. In order to avoid any discrepancies, I put parentheses in some of them. So if I click here and say equal, 4 is equal to 4, true. 4 is equal to 3 is false. 4 less than 2 is false. 4 less than or equal to 2 is also false. 4 is greater than 3 is something is not working well here. Let me check that. I may have entered text. So I'm going to press the parentheses and say 4 less than 3 equal. 4 is not less than 3, so that's equal to 0. 4 greater than or equal to 3 is true. 4 is not equal to 4 is false. 4 is not equal to 3. Oops. Apologize for that. Is equal to true. Okay, so there you go. When you have 1 is true, when you have 0 is false. And so those statements. So the results of a comparison is a logical statement because it takes the value of 0 or 1. And those statements, those comparison statements are useful in programming. Now, when you have logical statements, they can be combined in different operations depending on whether they're true or false. So let P and Q be logical statements. So these are statements that could have a 1 or 0 value, that means true or false. The operation that we can apply is the negation, is a unary operation in the sense that only applies to one statement. And what it does, it changes from true to false, from false to true. Then we have the conjunction, which is represented by the and that is true only if both statements are true. The disjunction, represented by or, is true as long as one of the statements is true. And then the exclusive or, sort of an extension to the logical operations, occurs when both are true or both are not true. But if one of them is false, then the statement is false. And so these combinations are used also in programming. The results of combining these two logical statements using the negation, conjunction, disjunction, or exclusive or depends on whether the proposition P and Q are true or false. This is, I mentioned, is binary. In other words, the negation of true is false, the negation of false is true. But when you combine AND, OR, or XOR, you have to see all possibilities. True, 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 false, false, true, false, false. In this case, in AND, it's true only if both of them are true. In the OR statement, as long as one of them is true, oh, I'm sorry, I made a mistake here. That should be true. I was kind of copying the one. So they are true in all these cases, except in the very last one where both are false. And the exclusive OR are true if both of them are true or if both of them are false. Otherwise, they are false. So let's see some operations here, some logical operations. This statement is false. The negation of that statement has to be, I think I changed the sign here. Actually, it should be 3 greater than 4. So I can negate it, and that negative negates to 1. This is true. The negation of that should be false. Conjunction. 4 greater than 3 is true. 5 less than 7 is true. Both of them are true. The combination is true. But 4 greater than 3 is true. But 5 is not greater than 7. So there is a false statement right there. And true. I'm sorry. False and true. False also, and in this case both of them are false, and you get a false statement. In the disjunction, as long as one of them is true, the statements are true. And so in the first case both of them are true, in the second case 4 is greater than true, then 5 is less than 7, and so there remain 3, but in this case both are false. Oh wait, I meant to change these to or less than 3, and or 5 greater than 7. None of them is true, so both of them are false. The exclusive disjunction, true and true. Wait, let's see. 4 greater than 3, 5, or 5 less than 7. Okay, 4 is not greater than 3. 4 is greater than 3. Or okay, let me check something here. 4 greater than 3 false, 5 greater than 7 false. Okay, so I got this wrong. If both of them are true, then this is false. If both of these are false, if one of them is false, they are true. Like in this case, this is true, and this is true, the combination gives me false. This is true, and this is false, this combination gives me true. This is true. This is false. Give me true. And in this case, both of them are false. No. This one is false. Is false. Yeah. So let me change that to 4 greater than 3, and that gives me a false. All right. With this video, with this exercise and completing the video corresponding to applications of the Boolean panel in SMath.